A cell phone executive has recently been bombarded with complaints from his customers about defective cell phones. He has two plants which produce the cell phones, and he is not sure where the defective phones are coming from. In the past, the plants have had good control over the number of defective phones produced. Because of this recent flurry of complaints, he thinks that one of the plants may have lost control over its production process. To test this theory, he randomly selects 200 phones from each of the plants and counts the number of defective phones. The results of the survey are displayed in the table below. Is there sufficient evidence for the cell phone executive to conclude that there is a difference in the proportion of defective cell phones produced by the two plants at a significance level of 0.10? Okay, so we have ourselves a hypothesis test here. And as we look over the last slide, and this one as well, we can see that we're comparing two groups. And what we're comparing about the two groups is the proportion of defective cell phones. So I have a hypothesis test of two proportions. We have legitimate sample data for each plant. So as I think about that, I want to make my hypothesis statements. So here is my null hypothesis. Proportion for plant A is equal to the proportion for plant B. I just gave them A and B subscripts here so I can kind of keep it straight. So that is our first and our null hypothesis. Now, because it said there is a difference here, it didn't say one plant was more likely to have defective phones over the other, then my alternative hypothesis has been limited to the proportion from plant A is not equal to the proportion from plant B. So I have a not equals to or a two-tailed test that we'll do here. So as I'm sort of gathering my thoughts on how to do this in Rguroo, I want to revisit and see the data again. So again, everything seems to be pointing at this idea of a defective phone. So in theory, that will be what my success is a defective phone. Doesn't sound like a success, but that's what the executive or the manager wants to test about. So here are our sample proportions, just grabbing these numbers right out of the table for each of the plants. So 12 out of 200 for plant A and 10 out of 200 for plant B. So keeping all that in mind, let's head to Rguroo and let's see if we can get this information in there so it can do all the hard work and complicated calculations for us. So let's escape and pull up Rguroo. All right, here we are. Rguroo is open. I'm just going to come in and go to Analytics, open that panel up, choose Proportion Inference. It's the first one, and two populations since we're comparing two groups. I'm going to walk slowly through all the things you need to tell Rguroo to get it to do all the calculations for us. We do not have a data set here, so I won't do that. We simply have the numbers from the summary table. So we're going to do a response level and label, and that's going to be cell phone status. All right. And honestly, you can put anything there. You don't have to put exactly, but just a label. Our success. Now remember, a defective phone is, or just defective would be fine, is our success. So our failure would just, we can label as not defective. All right. The other thing here that says label is just population. So maybe I'll just put cell phones there because that's what we're looking at. Having a little trouble spelling today. There we go. So really all these are needed for is just to make a really pretty output for Rguroo. So that's why they require these. So here's where we tell it the sample evidence. So we have two populations here. The label here is, I'm just going to call it A for plant A. And the sample size was 200, and there were 12 phones that were defective. Now, you can see underneath it does that calculation for us. 12 out of 200 is 0.06. Plant B, they had 10, oops, it's the sample size. I need to read. Sample size, the number of successes, they had 10. So these gray boxes are filled in automatically. You don't have to type that in. Now, we want to do a hypothesis test. So I'm going to click on Test of Hypothesis here. And I need to let Rguroo know what my alternative hypothesis looks like. Now, this is a slightly different format. They like to do the difference of the two. Nonetheless, we are going to put the not equals to there. That's our alternative. And this is how most computer programs will write not equals to. An exclamation point followed by an equals means not equals to. And then here we put 0. Always put 0 in our course here when we're testing two populations. You can change the significance level if you want. If you remember, ours was 0.10. Oops, I got to put it there. And finally, because I've learned if you don't check one of the methods, it will not actually do the test for you. So you have to tell it we're doing a large sample Z. Now, I know it's a lot to remember, but it's really worth it when it does the complicated calculations for us if you've ever tried one of these by hand. All that is set, and we will click on the preview, and we get a ton of output here. The first one is just the table that we had earlier with an extra column. So we have 12 defective. That means there's 188 that are not defective. So it gives us back the information we gave it. Just double check that you didn't mistype something. But the real thing we're really interested in is this second table. And you can see we've got proportion A, proportion B. The difference between the two, there's a 1% difference. So 0.01 as a decimal. Here is our Z-stat. That's our test statistic, or our Z-stat at 0.4386. If I look over, we're using the p-value method in this course. So there is my probability value, otherwise known as a p-value. So let's go back and let's use the two pieces of information, that is the observed stat and the p-value, and let's talk about how to make a decision for the hypothesis test. All right. Here we are again. So there's our output. I just wrote down the two things we discovered. Our Z-stat is quite small. It's not, there's not even a one standard error difference in these two at 0.43, not even a half. But really that p-value is what we're using in this course. So 0.6609. So I'm just going to repeat it down here and set it to the left of my significance level of 0.10. So now I have two known quantities side by side. And I just want to evaluate which one's larger. Well, it's obvious that the p-value is greater than or larger than our significance level. And when that happens, we are to fail to reject the null hypothesis. Now, I always like to rewrite the hypothesis and just get my mind to focus in on what this means. So I'm just putting them there again. So when I fail to reject it, that means I have to keep the null hypothesis. And the alternative hypothesis is not in play anymore. There's no data to say that the alternative is true. The data we have is more supportive of the null hypothesis and not of the alternative. So when I go to write a statement about this, I see that there is not sufficient evidence for the cell phone executive to conclude that there is a difference in the proportion of defective cell phones produced by the two plants. That sounds a little bit wordy, but I'll be honest, I borrowed a lot of the language for this question from the actual, or for the statement here, from the actual question that was given to us a slide or two prior. And I just adopted it and changed it to indicate what we found. And that is that there's no evidence to show that there's a big difference in the proportion of cell phones that the two plants are producing. So for me, that means they're essentially equal, which is, you can see what we circled above. I hope that helps. Reach out if you need any help with this, and we will try to work through some more of these.